tell you a little bit about my own story as I'm talking about Kubernetes and containers in general. Sorry about that. Okay, so when you want to use Kubernetes, you're probably aware that Kubernetes is an orchestration tool for containers. It's kind of the grandson of Borg. And whoever is familiar with a little bit of Google history know what Borg is. If you don't, by all means, go look. It's very interesting. So because it's an orchestration tool for Docker or containers in general, you should start with Docker, you know. And when people are started using a NoSQL database, it doesn't matter if they're coming from a different one or if they're their first time using NoSQL. I think it's very useful to be able to do things in a kind of DevOps manner. So you don't need to have a cloud account. You don't need to have, you know, a lot of servers available to you. You can start with Docker, and what I'm saying here is that before you go into your, you know, planning for production, you're planning for your entire full stack, by all means, first get acquainted with Scylla, get acquainted to CQL, if you're using a particular language, play with that language and with Scylla before you think about all those great things that you saw in the other presentations, like, you know, performance, all the cutting edge things that the engineers are delivering to you. But when you start with Docker, there are some things you should have in mind. Like, you're not expecting the best performance ever, because you're probably, you know, just running on your laptop or some old machine. You're doing, you know, things like testing functionality. So, for example, we were talking about materialized views or the in-memory feature for Scylla. So that would be a good use case. So right now you want to see how that works. How do you configure? How well it's playing? You're simulating, you know, small operations, creating tables, creating key spaces, playing with replication factor, consistency level, and so on and so forth. And above all, having fun, because Scylla is a Glauber said it's a boring database, and that's true. After you go to production, you kind of forget that it's there, right? But when you're creating whatever you're creating and using Scylla as the database, for me it was a lot of fun, and most people give me the same feedback. They say that it's fun to play with Scylla. Because of the reasons that I just mentioned, you know, maybe you're just testing on your laptop. Our Docker container, by default, it ships with developer mode on. And why is that? Because Scylla is very demanding in terms of the environment that you are deploying. So when you install Scylla, it's going to verify for, you know, the proper amount of resources, CPU, RAM. It's going to benchmark your disks, right? So, and sometimes if you don't have the correct proportion of resources, or you don't have enough resources, what's going to happen is Scylla is not going to start. But developer mode relaxes all these checks and verifications so that you can run Scylla nevertheless, you know, independently of having all the proper resources. Another good use of Docker for Scylla is sometimes you're having a problem in production or on your test environment, but you have a lot of data there. Sometimes you cannot touch whatever is running there. You cannot modify the data, or you cannot test something. So a lot of times when I'm working with customers, what they do is they create a very simple procedure to reproduce that problem on Docker, and they just pass that procedure to me, and then it's really easy for us to identify what's failing or what configuration is not correct, and this way to bring you a solution. After you're past that, after maybe you were playing with your data model, maybe you were playing with a new feature, you were trying a new experimental feature that we are providing, then you can start planning for production, right? And I think one of the most important aspects before you do that is that you are very acquainted with your underlying infrastructure. So you should know what are the speeds of your disk, for example, because I keep telling people that Scylla is not, it's going to work with spinning disks, but it's going to become a bottleneck really fast because we are extracting every bit of resource from CPU and memory and networking. So usually the bottleneck will be the disk. Again, because of our dual sharding that Glauber explained on the welcoming session. So we're sharding the data by node, but we are also sharding the data by CPU. If the CPUs are not properly isolated, you're going to have context switches, and this is going to impact your performance. So it's very important when you're using a container that you are taking steps to ensure that those CPUs are isolated from everything else in that host or from other containers running in parallel. So, okay. We did some testing, we did some benchmarks on Docker. There's the link right there. You can go to that later. But we found that the reasons for performance degradation inside a container were resources not being properly isolated. I mentioned context switches, and because think about it, it's just like what we had with virtual machines. You have another layer of abstraction. Of course, containers they have a lot less abstraction than we have with VMs, but there's still some things that are there and they are consuming resources, right? Remember what I mentioned about disks? One of the things that we have been doing with customers when they're going to a new machine, a new type of instance, and they want to, I mentioned you should know the speed of your disk, right? So when you turn off developer mode on Docker, what's it going to do? It's going to run all those checks that I mentioned before. And one of the first things Scylla will do is run Scylla.io setup on Docker. And then you see exactly what are the capabilities of your disk. If you have a laptop with a spinning disk, you can run, pointing to that volume, and then you can plug a SSD and do the same thing. You see the difference. So be very cognizant and very aware of the speeds of your disk, so you know what you can expect in terms of performance from Scylla. Going back to that. To the article that I mentioned. This is a test we did on i3 Metal on Amazon. And you can see that the green one, it's Docker with developer mode on. So no tuning, no parameters. We are not telling Docker anything about the underlying infrastructure. You just go Docker run Scylla, and there you go. You have one instance of Scylla running. And then we started, we were wondering, comparing to the AMI, which is the blue graph, wondering why the difference was so big. And the first thing we noticed is that the CPUs were getting hit by interrupts and by other things running on that host that Docker was running. So by just pinning the CPUs on Docker, we got rid of this. And you can see it's a huge difference. So we went from 137 IOPS to 391. So we get most of the performance just by using CPU pinning. And of course, we're never really happy until we know everything that's happening on the background. So after that, what we saw is that Docker has a virtual network, and that was, as I mentioned, it's another layer of abstraction. So when we added the option of running on the network host, then you can see it's almost the same as the Scylla being installed directly at the VM on i3 8X large. So, and there's still a little difference there, right? That's like, I think it's around 3% difference. And that, of course, is, because of the C groups that Docker uses. But if you get rid of that, there's no point of using Docker at all, right? These are the results for latency. You see that it's pretty similar to Throughput. So, as we add those extra options, we get the performance back, and it's very similar to our AMI, for example. After you're done with Docker, I really recommend that you start with Docker, because then you got familiar with the container part, right? And then you go for the orchestration. Because sometimes I saw people starting with Kubernetes and getting really confused about what was going on inside it. They understand pods, they understand, this structure, but they didn't know how to dig in and go to the container and see what was happening. So start with Docker, then move to Kubernetes. And this will give you a better learning experience. So with Kubernetes, let me go back a minute. So we have this infrastructure in Kubernetes. So you have several bare metal machines. You create a Kubernetes cluster. You have one or two master, and the other are workers or nodes. And inside those nodes, Kubernetes is declarative. So you tell the Kubernetes cluster how much resources you want, what you want from them. You can run a Docker image for applications, application servers, and in our case, a database. And it will just match what you declared and give you the resources that you asked. But Kubernetes is used usually for stateless application. And it was created with stateless applications in mind. So for a while, they had to create new resources or new modules, so to speak, in Kubernetes to address the needs of stateful applications as a database. Stateless applications, they don't need persistent, they're perishable. And stateful applications are, persistent. They usually unique, and they need to be deployed in an organized manner. manner. You cannot just deploy multiple instances in parallel because they need to talk to each other. They need to be in sync somewhat. So these are some of the structures in Kubernetes that we use to deploy Scylla. The first one is the storage class. The storage class is heavily dependent on your infrastructure, the types of disks that you have, the type of hardware. So usually you create the storage class based on what you have available. And after you have that storage class, you'll be able to use that later in the stateful set. And the stateful set is this structure that was created in Kubernetes to address those stateful needs. And the config map is the structure that we use to map the config file for Scylla. In our case, it's the Scylla YAML, or if you are deploying on a multi-DC or a multi-rack environment, then there's the Cassandra rackd property file that we create, has a config map that it's going to appear inside your pod, has a plain file, right? So going back to disks, so as I mentioned, the storage class is kind of the specification of the disks that you have available for your Kubernetes cluster. On the third step, you see that there's the persistent volume claim. So inside the stateful set, what we have is a volume claim, which is going to tell Kubernetes, hey, I need a volume, And you're also going to declare the storage class that you want, and the Kubernetes cluster is going to provide you with a persistent volume. This persistent volume will be attached to a pod through a persistent volume claim, and then you're going to see it has a file system inside your pod. In this case, varlib Scylla. And this is a very simple, very small example of the Scylla YAML. If you go to our GitHub, you'll see that the Scylla YAML with all the options, it's all commented out, but it has like 800 lines because all Scylla options are available there. But I'm just showing you one option, which is the cluster name. But you get the idea here that you have a config map. This config map is called Scylla config. Scylla config in turn will be mounted as a volume inside the Kubernetes cluster, and this volume is going to be available on the pod as a volume mount. And in this case, this config map that I created on the first step will appear inside the pod as etc Scylla YAML. So, but there are two ways to pass configurations to Scylla. So one is the Scylla YAML file. The other one are the parameters or arguments that you can pass to the container itself. And there we go. So, for example, if you are turning off the developer mode, as I mentioned in the beginning, this is how we do it inside the stateful set. So we have the stateful set. Inside the stateful set, you have a section for the container. And inside the container section, there's this option called args. So all the arguments that you can pass to our container, that's how you do it. So the name of the arg and the value that you desire. So, as I mentioned, for Kubernetes, we have all these manifest files, like the stateful set, the config map, the storage class, and there's so many others. I'm not trying to give a Kubernetes class here, so I assume that most of you are familiar with all the pieces, but it's a little annoying, at least it was for me, to deploy each piece, individually. I wanted something more automated that would flow better. So what I did, my first experience was to create a Helm chart. And Helm chart is kind of a packaging system for these manifest files. And we have one available on our Scylla code example repository on GitHub. And you see there that there's much more than I'm showing right now. So they're much more complex, but all those little pieces that I showed in this presentation are there too. So it will be easier to read and to get acquainted with that. So we have the Helm chart, but because Scylla has all these let's say those guarantees, in Scylla it's a database that was designed to extract every bit of resource from the machine. When you put all these abstraction layers, it can get a little other than the performance, it can get a little difficult to handle. So, and of course, there are daily operations. There is what you're doing with Scylla. So, for example, a use case from a customer was during Black Friday, they wanted to grow the cluster because they were expecting more sales, which means more throughput, more operations. But after the Black Friday, they didn't want to, keep the machines because, well, they don't have that amount of traffic, right? So you need to decommission a node, for example. And right now, the manifest files in the Helm chart is very good for you to deploy a cluster and even to grow a cluster. It's very simple. It's like one command, there you go. But when you need to get rid of a node, for example, then it's all manual. So you have to go there, you have to go to the pod, you have to run node to decommission, you have to wait for the streaming to finish, and then you can get rid of that pod. Right now we are creating an operator, which is yet another Kubernetes structure to handle, all the manual operations that people has to run during the life cycle of the application, but we are trying to automate all those tasks. So we have the first version right now. It's very, only even say beta is alpha. It's very small right now, but it already deploys a multi-AZ cluster. And all you have to do is kind of modify like 3 or 4 things in the file, and there you go. One of the things that I wanted to do is to invite you all to join on our Scylla Slack, the Docker channel and the Kubernetes channel, because one of the things that makes my life much easier is when I have real use cases, real users, real customers using Scylla on Docker and Kubernetes, because it doesn't matter how much planning I put into it. There's always corner cases that you're just going to find out in the real world.